So in this video, we are actually going to go over the equations or the formulas that we are going to use to solve the problems. So many problems in this chapter is going to be solved by using these formulas. I said in the initial video that mainly some problems you will solve by equations and some other problems you will solve by using the graphs. So, but this techniques will be used all throughout your mechanics. Even in other chapters, in some parts, you'll have to use these formulas. So they are commonly known as the suvat equations. So v equals to u plus at. Here v refers to the final velocity and u refers to the initial velocity. So in a motion, and in all of these formulas, actually the acceleration has to remain constant. You're dealing with constant acceleration. So final velocity at the end of the motion, and u the initial velocity at the when t is equal to 0 at the beginning of the motion. A stands for acceleration, t for the time. Actually, if you look at it, this is the same as a equals to v minus u by t. That is, constant acceleration is equal to acceleration is rate of change of velocity. So change in velocity, final velocity minus initial velocity divided by time. Okay, you just rearrange it to get this equation. Then you have a is equal to half u plus v into t. So this equation, basically this part is just the average velocity. You can use this formula for average velocity when the acceleration is constant. So displacement will be what? The average velocity into time. The displacement is going to be average velocity into time. So this part, half u plus v by 2, this part is called this is the average velocity. A is equal to ut plus half at square. A is equal to vt minus half at square. So this formula actually I haven't used. It's less important than the other formulas, but you should know it nonetheless. So S refers to the displacement, and you're already familiar with like u, a, t. U is initial velocity, v is final velocity, a is acceleration, which has to remain constant for all of these equations, and t is the time. Then you have v square is equal to u square plus 2as. V square is equal to u square plus 2as. So how actually use these formulas? So it depends on what terms are given and what term you have to find out. So let's say you don't have to find anything related to displacement, distance, and also no such term is given. For example, the value of s is not given, and also you don't have to find the value of s. So this equation in that case will be very, very, very convenient. Let's say the question has nothing to do with the final velocity. It is neither given nor you have to find it out. Then you can use this equation. Okay. Let's say the equation has nothing to do with the time. The time is not, that is, I mean that no time is given, and you also don't have to find the time. So then this equation is quite helpful in that case. And also in some questions maybe you don't find the required time using one formula. Maybe you have to use two steps. Maybe you find the time using this formula, then maybe you insert the time over here to find the displacement in this way. Okay. And also just also feel free to actually, let's say you start with this formula, but you see that you cannot do the sum using this formula. Let's say there are two variables. No problem, you move on to another formula, because there are only a few formulas over here. Okay, so basically as you practice, it will be much easier for you to apply the correct formula instantly. So now, so exercise 1b, actually there is not much to do. So I'm moving on to exercise 1c, question number 6. The car is traveling at a velocity of 20 meters per second. When the driver sees the traffic lights ahead change to red. Let me start from again. A car is traveling at a velocity of 20 meters per second when the driver sees the traffic lights ahead change to red. It decelerates at a constant rate of 4 meters per second square and comes to a stop at the lights. Find how far away from the lights the driver started braking. So actually it's better to initially in the initial stage, so let's write down the formulas. V equals to U plus AT is equal to UT plus half AT square is equal to half U plus V into T. So gradually you should actually, these formulas will be not only memorized, like you have to internalize the formula. Okay. Is equal to UT Vt minus half AT square. So let me read the question fast again. A car is traveling at a velocity of 20 meters per second. When the driver sees the traffic lights ahead change to red. So you actually know the initial velocity. The initial velocity is actually 20. It decelerates at a constant rate of 4 meters per second. So the value of A is going to be minus 4 because it's decelerating and comes to a stop at the lights. So your final velocity, at the end of the motion, you're coming to stop. So your final velocity is actually equal to 0. How far away from the lights the driver started braking? So actually, if you notice that no value of time is given in the question, and at the same time, you have to find the time, like how long it took for the car to come to stop. That's not something that you have to find. So actually, we can very easily use this formula: V square equals to U square plus twice AS. So you simply insert the values. So 0 square is equal to 20 square plus 2. The value of A is minus 4 S. So the value of S is 50. So what did they have to find? How far away from the lights the driver started braking. Okay. So basically this is the same as the let's say from here. So here you have the lights. So this is the distance it took for the car to come to rest. So that's the distance we have found, and that's the same as the how far away from the lights the driver started braking.